Hello everybody, we're getting ready to start 3.12 Part 2 SAT Math Level 1 Test Prep. Here's the contact email. Let's do 3.1212 Part 2, Working with Functions. Here are notes here. We have a 48-point skill sheet, which is not included with this PowerPoint. To get that, contact me. Okay, notebook here. This should go in your notebook guide. Determining the domain and range, unless otherwise indicated. The domain of function f is the largest possible set of real numbers x for which f of x is a real number. Do not divide by 0. Exclude from the domain of any function the value that represents division by 0 here, so no zeros in the denominator. Since division is not allowed, don't even think about it. Okay, do not take the square root of a negative number. That we get into other areas there that we're not going to deal with in the SAT level 1, not in this section anyway. The range of the function y equals f of x, set of all values that y can have as x takes on each of its possible values. Composite function notation. Output of one function can be used as the input of a second function. The notation f of g of 2 means that the output of function g when x used as an input for function f of x equals 3x minus 1, and g of x equals x squared, then g of 2 would be this here, 2 squared equals 4, so f of g of 2 would be f of 4, which would be 3 times 4 minus 1. In general, f of g of x and g of f of x do not necessarily represent the same value. For example, using the same definitions for function f and g, if you were to do this over again, you would get 25 here. So f of 2 here would not be, see, those would be called inverse of each other. That doesn't necessarily happen all the time. Some values of function f of g are given by tables here. So here's a table. Here's another table. What is the value of f of g of 3? So, for in this case, could it be these values here? It's one of these values here. X equals 3, so g of 3 equals 1. So if x equals 3, then g of 3 would equal 1 here. So f of g of 3 would equal 4. So 1, and then when x equals 1, y equals 4. That'd be one way you could do it, would be with a table. Representing a sequence of numbers. For example, the first term of order sequence of integers is 4, then f of 1 equals 4. If the nth term of the sequence is given by the function f of n minus 1 plus n, then successive terms of the sequence after first can be attained by replacing n 2, 3, and 4, and so forth. For example, to find the second term of this sequence, set n equals 2, and we plug in 2 here. Since it is given f of 1 equals 4, f of 2 would be 4 plus 2, which would equal 6. To find a third term of the sequence, set n equals 3. So f of 3 minus 1 plus 3. So f of 3 would equal 2 plus 3, which would equal, from the previous step, we know that f of 2 equals 6. So f of 3 would equal 6 plus 3 equals 9. Math reference fact. Function may be defined explicitly or recursively. A function defined in the usual way as y equals type of equation is defined explicitly. A function such as f of n equals f of n minus 1 plus n, where f of 1 equals 4, is defined recursively, since each of its value after the first is calculated using function values that came before it. So graphs as functions, as a graph set of ordered pairs, like this here, is a function of a graph. The domain of G is -6 to +5, since the greatest set of x which the graph extends horizontally is from -6 to x is 5. The range of G is from 0 to 8 here. Here's your range here. The vertical extends vertically from 0 inclusively, so The line y equals 2 intersects the graph at 2 points. So, for which g of x equals 2, to find g of negative 1, determine the y-coordinate of the point on the graph whose x-coordinate is negative 1. Since the graph contains negative 1, 6, g of negative 1 equals 6 here, up here. To find a value such that g of t equals 2, find all points on the graph whose y-coordinates are 2 by drawing a horizontal line through 0, 2. Since the graph passes through negative 5, 2, negative 5, 2, 1, 2, 4, 2, g of negative 5 equals g of 1 equals 2, and g of 4 equals 2. Hence, the possible values of t are negative 5, 1, and 4. Negative 5, 1, and 4. Finding the zeros of a function. The zeros of a function f are those values of x, of any, for which f of x equals 0. You can determine the zeros of a function from its graph by locating the points at which the graph intersects the x-axis. At each of these coordinates would be referring to the graph, which could be the value of s when g of s equals 0. So when g of s equals 0, this would equal negative 6, 2, or 4 for that situation. 1 only, 2 only, 3 only, 1 and 2 only. So since graph of function of g as x intercepts x equals negative 6, g of 2 equals 0, because s can be equal to either 6 or negative 2, Roman numeral choices 1 and 2 are correct. 1 and 2 are correct. The correct choice would be D in this case. So in your notebook, again, the zeros of a function of this 25 minus x plus 2 squared are, here's our selection here. That's to find the zeros of s at f of x equal to 0. So we move our, what do we do here? We just make this equal to 0. Since negative 7 plus 2 squared equals 3 plus 2 quantity squared equals 25, the equation will be true when x equals negative 7 or x equals 3. The graph shows a function y equals f of x over the interval 0 and 7, between here and 7. What is the value f of 6? F of 6, negative 2, 0, 1, or 2. Reading from the graph of f of 6 equals 2, so f of 6 equals f of 2. So when f of 2 equals this here, we get negative 2 for our solution to that one. This is 3.12 part 2. If you need worksheets, other materials, email me here. Thank you.